Hey everyone, welcome to Calculus. This is section P2, and we're talking about linear models and rates of change, aka slope. This is going to be a huge part of what we're doing here in Calculus, and so just a good quick refresher of what slope is. I'm sure you probably remember it, but it's always good to check it out. So remember, slope is the same as the rate of change, or delta y, change in y over change in x, which is y2 minus y1 over x2 minus x1, which is the same as m. All those things mean the same thing, and they're all going to be super important for what we're doing, because we're talking a lot about slope as far as calculus goes. So here are some equations of lines that you're probably going to need to know. Slope-intercept form, y equals mx plus b. Point slope form, y minus y1 equals m parentheses x minus x1, or another form that I kind of like to write it in is y equals m parentheses x minus x1 plus y1. So either way is going to be okay. Then there's also general form, ax plus by plus c equals 0. Vertical lines, x equals a, horizontal line, y equals b. Doesn't really matter which type it is. I mean, these are just arbitrary letters, so who cares if it's A or B? All right, remember, lines that are parallel, the slopes have to be the same. And remember, perpendicular lines, the slopes have to be opposite reciprocals. So all that stuff is just a good refresher for lines that you're going to need to know. All right, so now let's just do a quick example, just so that way you can kind of refresh yourself a little bit on all this line stuff. It says write an equation. I know it looks kind of weird. It looks like dn, but it's really not. It's an. It's an. Write an equation in as many different forms as possible. Then write an equation of a line that is parallel and perpendicular to a line that has a slope of -3 and a point of -2, 4. One big thing you probably want to do a lot here in calculus is to draw a picture. All right, so we're going to just plot our point -2, 1, 2, go up 1, 2, 3, 4. And make our point, and then we're going to go down 3, 1, 2, 3, right 1, down 1, 2, 3, right 1, down 1, 2, 3, right 1. Alright, and then we'll use our handy dandy straight edge right here, which is just the side of a marker box. And I didn't do so well, but you get the idea of what this looks like. Alright, so there's our line. We can always graph it. So we need it in many different forms. Remember the forms we had before? Let's do slope-intercept. Well, where is my intercept at? My slope is -3, so we're going to say y equals -3x plus, and my y-intercept is -2. 1, 2. So there's one form. Next would be point slope form. Y equals -3 parentheses x plus 2, and then plus 4. Right? Or we could also write it as y minus 4 equals -3 parentheses x plus 2. All we're doing is switching everything around. Okay, if we want it in general form, ax squared plus bx plus c equals 0, I would just take this one, move the y over there, and move the y to that side, and we pretty much have it. So it would be -3x minus y minus 2 equals 0. A different way, some people don't like that for general form. They don't like all those negatives, so we could also say 3x plus y plus 2 equals -0. Either way will be okay because we just multiplied everything by -1. Alright, so there's general form. We can't write this as a vertical line or a horizontal line, obviously. Okay, so then if we want to write a line, an equation of a line that is parallel, as long as the slope is the same, that's all we really need to do. Y equals -3x plus 17, or whatever this is, as long as it's not -2, we're going to be okay. Alright, and the last one is perpendicular. Remember, perpendicular is opposite reciprocal. We want it to be going this way, so it should be going positive, and it should be going up 1, right 3. So the slope should be positive 1/3. So you get y equals 1/3 x plus 41. -2, whatever. There you go. See you later.